Hi, Mom. So, I learned this really cool thing in class about our immune system, and I'm sure you remember mine not working the best when I was a little kid, but we're going to kind of go into a little bit deeper explanation of that. So, a big part of our immune system, we have a cell, I think, called the mast cell. It's kind of they're all over. They can be in like our gut, our small intestines. It can be in our respiratory mucosa, so like when we breathe, it can be right in here. It's all over in our body, acting as a barrier. It's a inflammation response. They include histamine, which acts as early sensors for infection or injury. So if we feel like we're getting sick, we're getting a cold, flu, sinus infection, COVID, an injury, our body reacts and it knows that we're having an injury going on. It steps up and starts to recognize pathogens, and that's kind of where our immune system starts to kick in and say, hey, something's going on. And one of the first lines of defense that we have is our mast cells, and it's very important that we have them, and it's almost impossible to function without them at all.
My name is Savannah Curtis, and right now we're talking about mast cells. So to keep going, mast cells are activated by antigens that bind to IgE, which make them release granules such as histamines and other inflammatory mediators. So IgE, also known as immunoglobulin E, are antibodies that are produced by the immune system that cause an allergic reaction. Once these granules are released through a process called degranulation, there is an increase in vascular permeability, tissue inflammation, and also stimulates mucus secretion. So there are two types of activation when thinking of mast cells. First, there's secondary, and then there's also primary activation. Secondary activation is when there's a substance such as medications, an infection, or even a poisonous bite. And this is from the normal mast cells. And this is also from external stimuli. Then there is primary activation, which is when there is a mutation in the mast cells that cause there to be an overproduction and uncontrolled release of mediators.
Mast cells lie under the surface layers of cells in the skin, nasal cavity, stomach/intestines, and lungs. They also surround blood vessels and nerves. Mast cells protect the body from foreign invaders. They bind to receptors and release their granules. The primary mediators released are histamine, tryptase, chymase, carboxypeptidase A, and heparin. These mediators act on the surrounding tissues to dilate blood vessels to slow blood flow and make the blood vessels more sticky for immune cells. These effects attract immune cells into the tissue as well as make blood vessels leaky to allow antibodies in. The antibodies and immune cells work together to neutralize and remove the infection or toxins. Once removed, mast cells make anti-inflammatory mediators to stop further immune cells from entering the tissues. These mediators also promote rebuilding of tissues and removal of dead cells. The mast cell then regranulates to prepare itself for future infections.